This is the question. Sami, Yusuf and Partha, I'm back now. Let's start doing this question based on the equation which we did earlier. So what is given to you? That there is 3% dissociated acid. This is the degree of dissociation, percent of dissociation given, percent. Let's say the acid is HA. They're asking you to calculate Ka. So what is percent dissociation, children? Can you give me the formula? It is concentration of H plus over initial concentration of the acid times 100%. Am I right? This was the formula, right? Sami, you're writing this formula? Yusuf? Now, you have to just plug in the values. Do you know percent dissociation? Yes, 3%. 3.0%. Do you know concentration of H plus? No. We are going to assume it as X. You remember X from the rice table? X. Do you know HA naught? Yes. 0.15. Please be ready with your calculator. Times 100%. So what's the value of X? Percent cancelled. This is molar. So X is, Jyoti, X is 3.0 times 0.15 over 100. Get the answer. Yeah, please give me the answer of this equation. Get the value of X. Sami, value of X, please. Is 4.5 times 10 raised to a minus 3 molar. Perfect. Very good, Partha. Sanvi, good. Two significant figures because this number also has two sig fig. This number also has two sig fig. Answer will be in two significant figures. Now we want to know Ka. To know Ka, I have to write down the equation. Ha, aqueous, undergoing dissociation. Yusuf and Sami, can you type yes here? Are you there in the class? Yusuf, Sami. Okay, good. Sami, yeah, good. Ha, H plus aqueous and A minus aqueous. You remember I was discussing this with Yusuf and Sami were answering it. So it's the same equation. What's the initial? Now this is the reaction. Rice table. Complete it fast, children, now. Complete this table. What is initial? Initial is 0.1500. Change minus x plus x plus x. Equilibrium 0.15 minus x, x, x. Ka expression, concentration of H plus times concentration of A minus over concentration of He, which is x squared over 0.15 minus x. Do you know x? Yes, from percent dissociation. This one. So it means 4.5 times 10 raised to a minus 3 squared over 0.15 minus 4.5 times 10 raised to a minus 3. Put this number in parentheses. Yusuf, can you calculate this? Calculate this. Mhm. Calculator is needed. And I hope you have your calculators next to you. In the next class, definitely bring the calculator because we are going to do titrations, calculations based on titrations and buffers. Waiting for the answer. Up to two significant figures. Can you check? Are you getting this? 1.4 times 10 raised to minus 4. No units. Yes, Sanvi, good. You're giving me in three significant figures. Sanvi, answer should be in two significant, right? So take care of sig in free response question. Even in multiple choice questions, they are framing questions in such a manner that they are testing you for your understanding of sig figs. Ready for next? Read this question, children. Sammy, is this a base or an acid? Is it a base or an acid? Yes, any one of you? This pyridine is a base or an acid? Very good, Sammy. It's a base. See, Kb is written here. Kb. Kb is for this base, right? And is accepting a proton. It's very good, Sammy. Percent dissociation is X over. Now, what is X here? Is it H plus or OH minus? Because it's a base, right? So it is the concentration of OH minus. It's a base, right? It's going to dissociate in water to give you OH minus. No, in only in pH, Sanvi, only in pH you count the sig fig after decimal. But in other numbers, you just follow the sig fig rules which we did in 0 unit. Only in pH. Okay. Mhm. So it is the concentration of OH minus divided by concentration of C5H5 and the initial. Remember, initial is given multiplied by 100%. This OH minus is actually X in the rice table. So you can put it as X. You can put this number here, 0.10, 100% is equal to how much? Oh, that's what they are asking. That's the question. This is the question. That what is the percent dissociation? Okay, fine. So what is needed to know? X. How can I know X? Rice table. What's the rice table for a base? You remember? So now all of you please pay attention. For the rice table, what is needed? Water. Yes, yes, Athava. Write water here because otherwise you won't be able to make it. Water is going to behave like an acid and is going to protonate this protonation. See H plus. This one is gaining a proton. Gain of proton means base, Bronsted base. And water is giving a proton. So is Bronsted acid in this particular equation. These are conjugates. Now what is Kb? Kb is concentration of C5H5 NH plus. Children, I hope you are writing everything in your notebook the way I'm writing. Please don't be lazy in writing. C5H5N, right? Water is not the part of K. Yusuf, plug in the values. Do you know C5H5NH? Oh, I missed one thing. What is that, children? The rice table. This is the reaction. I missed the rice table, right? So what's the initial concentration of C5H5N? 0.10. H2O, not interested. 0, 0. Change minus X, plus X, plus X, plus X. Equilibrium 0.10 minus X. Water, we are not interested, right? Water is not the part. This one, X, X. Plug in these equilibrium concentrations. X squared over 0.10 minus X, which is equal to this Kb value. solve it, and again Partha is going to help us. Partha, can you give me the value of x, please? And thank you very much, Partha. If you don't have that graphing calculator, then I would have been doing them online. So whatever value Partha is going to give us, we'll accept it as such, and then later on you can check it. Yes, Partha, we are waiting for the answer. And the value will be of the OH minus, which can tell you the POH also, and then pH. Get the value. And the units are molar. Plug in that value here. Okay, we have to wait. Partha is doing calculations. Otherwise, children, you can also try it online. Just on the Google browser, type. There is a site which I'm generally using, and it's a good site, but I don't advise you to use this site because I want you to practice it. But for today's class, practice on your calculator. Okay, this is the site. You can plug in the equation here straight away. Okay, so Partha is giving us 1.3. Thank you, Partha. Thank you very much. 10 raised to power minus 5. So you have OH minus. Can you work out the percent dissociation? Yes, now we know OH minus 1.3 times, children, I'm writing here. Yusuf, here. 1.3 times 10 raised to power minus 5 times 100% over C5H5N, which is, what was the initial? 0.10. Get the answer in two significant figures. It's not a pH, right? So you're going to use simple sig-fig rules. Now this answer, I think all of you can calculate. Oh, Jyoti also calculated. Jyoti, you use the calculator or online? For getting the value of this x for this equation, Jyoti, you also did the answer very correctly. So are you using your graphing calculator or you did calculation online? Online means on the browser, Google search. Okay, so come in practice of using your calculator because in the exam, calculator is there in your hand. Children, see what she's writing very honestly. See, you have to practice on calculator. That's why I asked her this question. So please, next time, all of you bring your calculators. And this answer is 1.3 times 10 raised to power minus 2. Percent. Unit is percent. There is a unit, percent, right? We are good with this question, children? Yusuf, we're not answering again. Let's erase this. Okay, now the next topic. So this is about, if you have not written, you can write it. This is about the percent dissociation and degrees of dissociation. The next concept is strength of oxo acids. Strength. Time left is less, but this is a very small topic and you will find it very interesting. If you remember, we can compare the strength of the acids by their Ka values, right? So there will be questions in which they will give you Ka values and they will ask you which one is stronger, which one is weaker. Very simple. Data is given, you just compare Ka and answer it. But if Ka values are not given and they are still asking which one is stronger, then we need to understand a concept. And I want all of you to answer here when I'm discussing it because you already know the things. It's an application of a concept which we have already done in periodic table. Electronegativity, oxidation numbers, So strength of oxoacids can be compared by comparing the electronegativity or the oxidation number. Oxidation number. En means electronegativity. On means, what is the meaning of On? Oxidation number of the central atom. Central atom. You are going to compare the electronegativity and oxidation number of the central atom, right? Okay. Let's see the meaning. I'm giving you two oxoacids. One is HNO3, other one is HNO2. Which one is stronger? You already know. Which one is stronger? Which one is stronger, children? HNO3. Nitric acid. Nitrous is weaker. Now let's prove it by this concept. These two. Here the central element is nitrogen. And then you have the Lewis dot structure, which we have done in detail. But your oxygen, this oxygen has hydrogen, this hydrogen, acidic hydrogen. It is not on acid. In oxoacids, acidic oxygen is always on, acidic hydrogen is always on oxygen. The bond is like this, always. It's not on the nitrogen or sulfur or chlorine. No, it is on the oxygen. You draw the Lewis dot structure. This is the Lewis dot structure. And what about this? Here, this has a plus charge. Nitrogen, formal charges, the one which we discussed earlier. This is the Lewis dot structure of your HNO2, right? If you check the formal charge here, there is no formal charge on nitrogen. Yeah, good. This hydrogen is acidic. This hydrogen is acidic. Central element is nitrogen. Nitrogen. So I cannot use first factor because electronegativity is the same. I'm going to work with the second factor, oxidation number. Can you calculate the oxidation number of this nitrogen? Unit 4, children. I gave you the rules for oxidation number. We can assume it as X. Hydrogen is +1. Oxygen is -2. So 3 times -2. So it is X +1 plus 3 times -2. What is the charge on HNO3? 0. Review the oxidation number rules. And the answer is +5. Yeah, this one is +5. Use the same rules here. Get the oxidation number of this nitrogen. Hydrogen is +1. It is there in the rules. Nitrogen is X 2 times -2 and that equals to 0. Yes, Jyoti, very good. This nitrogen is +3. Very good. Jyoti Sanvi. Very good. I'm sure that unit 4 and 5 must be going in the schools. So they must be teaching you these oxidation number rules, net ionic equations. So which one is stronger acid? The one with high oxidation number. This one is stronger acid. High oxidation number is stronger acid. Stronger acid. Now let's try to understand the reason also. Reason is very important to understand. See, rule I can give you, but reason can help you in answering many questions. Let's try to understand why this nitrogen with high oxidation number is more acidic. Check this nitrogen, this one. What's the charge? +5. The other nitrogen, plus 3. Which nitrogen is more electron hungry, Atharva? Electron hungry. Which nitrogen is more electron deficient? Plus 5. So this plus 5 is going to pull electron density on itself more, right? It's more electronegative. It's going to take away the electron density from this oxygen. And oxygen will take away the electron density from hydrogen. And hydrogen will come out easily as H plus in this case. That's why it is strong acid. Here, this nitrogen is less electron hungry, less electronegative. Yeah. So even nitrogen, they are same. What I'm saying, this nitrogen is more electronegative because it is with high oxidation number. High oxidation number means more electron hungry, more electronegative, more electron hungry. So please understand this concept. So I'll start with this in the next class. Okay. If you have any questions, you can stay back. Yes, Sadhvi, you're right. See you then. Bye bye. Bye.